Hi students, welcome to SSJA Chemistry. First of all, thanks for your support. And today topic is electromagnetic spectrum, one of the most important topic for mains, aims and neet. First of all, coming to the topic, the word electromagnetic wave. The word electromagnetic wave, which is indicating that both electric field and magnetic field are present in a wave. Electromagnetic wave, both electric field and magnetic field are present in a wave. And these electric field and magnetic field, both electric field and magnetic field is there in a wave. So this electric field and magnetic field are perpendicular to each other. Okay, this is what called electromagnetic wave. Okay, this is what called electromagnetic wave. These three are important points. First point, the oscillating electric field and magnetic field produced by oscillating charged particles are perpendicular to each other. First of all, coming to the history, Newton's corpuscular theory is there. Newton's corpuscular theory. According to Newton's corpuscular theory, light are produced in the form of particles. Later, Maxwell came into the picture and he told, if the oscillating charged particle is there, if the charged particle is under acceleration, then the electric field and magnetic field are produced. See, the oscillating charged particle, if the charged particle is moving in this direction, if the charged particle is moving in this direction, then the direction of propagation is propagation of axis is this is the direction of propagation of wave. And if this is the direction of propagation of a wave, then electric field is in this direction. If the electric field is moving in this direction and magnetic field is moving in this direction. Okay, the electric field is moving in this direction and magnetic field is moving in this direction. Here you can observe both are in electric field and magnetic field is in perpendicular to each other. The electric field is moving in this direction, magnetic field is moving in this direction. Both are perpendicular to each other. Here down you can observe both are electric field and magnetic field is in the perpendicular to each other. Next point, unlike sound waves or water waves, electromagnetic waves doesn't require any medium. Actually, sound waves and water waves have medium, requires medium. Air is the one of the medium for sound waves and water waves. But electromagnetic wave doesn't require any medium. It can move in vacuum also. Means electromagnetic waves doesn't require any medium. So because it can move in vacuum also. So many members mistakes came into this electromagnetic waves. Okay, now electromagnetic waves doesn't require any medium. It can move in vacuum also. Okay, next point, there are many types of electromagnetic radiations which differ from one another in wavelength or frequency. Based on the wavelength and frequency, electromagnetic radiations are divided. Based on the wavelength and frequency, electromagnetic radiations are divided. So here based on the wavelength, first of all we should understand what is wavelength. If you consider this is a wave, then this is what called wavelength, which is indicating that lambda. This is the symbol for wavelength. Okay, now for this is the wavelength. If you consider this is a wave, this is the distance between the two crests or two troughs is called the wavelength. So this in this wave, this is the wavelength. Okay, so wavelength is indicated by lambda. Based on this wavelength and frequency, electromagnetic radiations are divided, and we have formula for wavelength and frequency. Nu is equal to C by lambda. Here lambda is indicating that wavelength and nu is indicating that it is a frequency. It is a symbol for frequency. Here C is the speed of light. C is the speed of light, 3 into 10 power 8 meters per second. For frequency we have units hertz, and lambda, for lambda we are using angstroms. For angstroms and meters we will tell. And there are, based on the wavelength and frequency, electromagnetic radiations are divided. Here, then what is electromagnetic spectrum? These 3 points, please note down this. Okay, please take screenshot. Next point. Then what is electromagnetic spectrum? Here electromagnetic spectrum means the arrangement of electromagnetic radiations in order of increasing wavelength or decreasing frequency. The arrangement of electromagnetic radiation, the arrangement of electromagnetic radiations in order of increasing wavelength, and or decreasing frequency, frequency symbol nu, wavelength symbol lambda. So based on the arrangement of electromagnetic radiations in order of increasing wavelength or decreasing frequency. So this is what we call electromagnetic spectrum. So first of all, the order of the arrangement is, first of all, cosmic rays, order, cosmic rays, gamma rays, X-rays, UV rays, visible region, IR region, infrared region, then microwaves and radio waves, See here, in visible we will observe VIBGYOR. What are colors we will observe? VIBGYOR, violet, indigo, blue, green, yellow, orange, red. This is the order. Okay, here from here to here, wavelength is increasing. From left to right, wavelength is increasing, and from left to right, if wavelength increases, then frequency decreases. Okay, from left to right, wavelength is increasing, and from left to right, frequency is decreases. Here you can observe the radio frequency, 10 power 6 hertz. Here hertz is the unit of frequency. And microwaves region, in the microwave region, 10 power 10 hertz. This is the 10 power 10 hertz frequency. UV region, 10 power 16 hertz. Visible lights, 10 power 15 hertz. Hertz means, here hertz is the unit of frequency. So the questions are like this, means they'll compare two regions, and they will ask questions which is having more wavelength and which is having less frequency. These types of questions will come like this from this topic. Okay, if you understand this topic, please share and subscribe. Thank you.